Okay, let's pick it back up where we just left off, and I gave you some data from 5 different tire brands, and the mean is the mean of the 10 cars with these tires and how many hours or miles, I can't remember which one it was, these tires lasted for. So you can see that on average the Bridgestone tires lasted the longest, and the Michelin tires lasted the least longest. So there's 10 cars that were using each of these tires, and here's our information. Here's our raw data. And then when we run our post hoc tests, you can see that what we're looking at here is anything with the asterisk, because it's saying that the difference is significant at the 0.05 level. So for Firestone, we can see that the only one it's significantly different than is Bridgestone. So Firestone and Bridgestone, there's a significant difference between those two. And if we look here, for Firestone, the only one that's significantly different from Firestone is Bridgestone, and that makes sense because it's the furthest one away. For Goodyear, the only tire that is significantly different from is Michelin. And if we look here, Goodyear to Michelin is the biggest difference there, so that makes sense. Michelin is significantly different than Goodyear and Bridgestone. And if we go back to here, we can see that for Michelin, it's significantly different than Goodyear and Bridgestone. Well, that makes sense because it's the furthest away from them. It's not significantly different than Firestone and Uniroyal. Uniroyal, the only tire that it was significantly different than was Bridgestone. And here's Uniroyal to Bridgestone is the biggest difference. And then interestingly, the Bridgestone tire is significantly different than everything except for Goodyear. So you can see here that Bridgestone is significantly different from Uniroyal, Firestone and Michelin. But the first two are not significantly different. So that's the power of the 2-key test for post hoc for ANOVA. So if we ran the ANOVA, all it would say is that there's a difference somewhere between these 5 types of tires. The post hoc test goes in a little bit deeper and says exactly where the differences are. So that's interesting information. So let's put that into words. And this is what I just told you. Bridgestone is significantly different than Firestone, Michelin, and Uniroyal. Goodyear is significantly different than Michelin. Uniroyal is significantly different than Bridgestone. Firestone is significantly different than Bridgestone. And Michelin is significantly different than Goodyear and Bridgestone. So this is powerful because it's telling us where the differences are between the multiple groups. So let's switch gears and talk about a repeated measures ANOVA. And this is an extension of a dependent group t-test. Remember, a dependent group t-test was 2 groups, but it was pre to post test of the same people. So in this case, it's still the same people, but we're measuring them more than twice. So in the table below, you can see we have an initial test, which might be a pre-test, a 3-week test, a 6-week test, and a 9-week test, which might be the post-test. So instead of just doing a pre and post, we've put these other 2 testing situations in. So this is known as a repeated measures ANOVA. So if we use this data here, we'd plug it into repeated measures ANOVA. And I know this is a poor copy, but I've got some better ones coming up on the next few slides. This tells us that when we compare the initial, the 3-week, and the 6-week groups to each other, that somewhere in here there's a significant difference. Okay, you can see it here at the 0.05 level. However, what we'd really like to know is where the differences are between these 4 groups. Okay, sorry I'm jumping around here. So this is that same information that we just showed in that example. So moving on to a factorial ANOVA. So far we've only dealt with one independent variable, and I'm pausing because this is where it gets a little bit tricky. So far we've only dealt with one independent variable. Theoretically, we can have as many independent variables as we want, although you rarely see more than 2 or 3. A factorial ANOVA is when we include more than one independent variable. We'll look at the case of 2 independent variables, and we're going to go ahead and call that a two-way ANOVA. And I've seen some of your proposals, and this would be the type of ANOVA design that you would be looking at using. When we do a factorial ANOVA, a two-way ANOVA, we get 3 pieces of information, or 3 p-values. When we do a one-way ANOVA, we just get 1 p-value. We also get main effects for each independent variable, and we got 2 main effects, and you're going to see this in the next few slides. But most importantly, we get an interaction effect, which is the reason we do a factorial ANOVA. So let's say we designed a study where we wanted to look at groups of people who are trying to improve their 5K runtime, and we put them into different groups. First of all, we separate by gender, male and female. Second of all, our independent variable, we have one group train in the gym, treadmills, and the other group train outside on trails. So one independent variable is running location. The other independent variable is gender, and the dependent variable is 5K time. So we'd have 3 pieces of information there. The interaction tells us, or is defined as whether the effect one independent variable has on the dependent variable is not the same for all levels of a second independent variable. So that's wordy and hard to kind of get your head around, but it's easy to see what it looks like in an example. Let's go back to the football data. Now we have 2 independent variables. Position, with 3 levels within that independent variable, and team, whether they're a starter or reserve. So we want to see if there's an interaction between these 2 independent variables for the 40-yard dash. So we have 2 main effects, 1 interaction. So there's 3 null hypotheses. The means runtime will be similar or not significantly different than the reserves. And the position, there will be no significant differences between the 3 positions, and that there will be no significant interaction between the 2 independent variables. So here's our descriptive statistics. So you can see now, because we got 2 independent variables, it's broken down into position, and within position whether they're a starter or reserve. Okay. And here's the number of people in each of those groups. Here's their means. So this is interesting. To do the interaction of whether they're of their position versus their starter reserve status, looking to see if it's the same pattern between starters and reserves for the 3 different positions. Are starters quicker in all 3 positions, or reserves slower in some positions and quicker in others? That's what the interaction tells us. So from that example, you can see what means are being compared in the 3 null hypotheses. This is what the two-way ANOVA source table looks like for the 40-yard dash. So there's 3 things that we're looking at here. The position, well, we can see that's significant. There's a difference going on here. Whether they're a starter or reserve, yep, there's a significant level going on here. And then there's also appears to be an interaction effect between the 2 independent variables. So there's lots going on in this example. So by having an alpha level of 0.05, we can see that there's a significant position effect, that there's a significant team effect, and a significant interaction effect based on all of those scores being lower than 0.05. So what we look at first is the interaction, because that always takes precedence, and then look at the means of each positioned group by starting status. So SPSS provides these nice little plots or graphs to show us what's going on here. So you can see the colored lines represent the positions, and the left hand side represents starters, over here is reserves. So you can see for these two positions, the blue and the red, that it's pretty consistent that the reserves are slower than the starters for the 40-yard dash time. So that's consistent. However, there's an interaction effect going on here, because for this third position, the green position, the starters are slower than the reserves. So if we go back to this definition here, interaction means that the effect of one independent variable has on the dependent variable is not the same for all levels of the second independent variable. And that's wordy, but all that's doing is explaining what's going on here. That there's a difference in how the dependent variable reacts to the two levels of the independent variable. So the graph shows we have an interaction because there's a disruption in the pattern across the independent variables. They don't all follow that same pattern. Here and there we have a nice pattern for the backs and linebackers, but the linemen do the opposite. So if our research question was, does the 40-yard dash time differ depending on the starting status? Our answer would be, it depends on the position. For the backs and linebackers, the starters are faster than the reserves, and we would say significantly faster. But for the linemen, the reserves are significantly faster than the starters. So that was our opening question. We collected data on our subjects, and then we ran our statistics, and that's what we found. So here's another example, and I'm trying to recall what this was showing. But anyway, we have two independent variables again, gender, and whether they're an athlete or non-athlete. And here you can see the means for each. Okay, so same kind of thing, showing us information. Another source table that's showing us there's a significant effect for gender, a significant effect for athlete, but because this is higher than 0.05, this is not statistically significant. So here you can see that for whatever this was measuring, I think it was scores on a test, that the males was higher than the females for the non-athletes, and the males were higher than the females for the athletes' scores. So this is significantly different than this, and this is significantly different than this, but there's no interaction effect here because they're both following the same pattern. There would have been an interaction effect here if the green line would have done this, because then the independent variables will be interacting differently with each other. But because they're following the same pattern, we can see that there's no interaction taking place. So here there's no interaction, but there's two main effects: the gender effect with males significantly higher than females, and the athlete effect with athletes significantly higher than non-athletes. And I guess here we were looking at the effect of gender and athletic status on ethical values. I probably need to put that title on an earlier slide. Okay, so let's now look at two-way ANOVA with repeated measures. And very often we're concerned with determining if one group changes more over time than another group. So we might have one independent variable with the dependent variable measured on multiple occasions, such as pre and post or more. And a two-way ANOVA with repeated measures, the repeated measures measures the dependent variable more than once. And this is very common in our fields because we often want to know if a treatment is more effective than a control group over different time points. We still have 3 null hypotheses, but one of them is now a time effect as one of the main effects. So let's look at an example. A physical education teacher wanted to know if music would improve the mile run performance of her 4th graders. We've seen this before, but we're extending this example. The students are randomly assigned to one of 3 groups. The control group with no music, the rock group that listened to rock music, and the classical music group that listened to classical music while they were doing their running timed workouts. So students were pre-tested on the mile run excuse me, and post-tested 4 weeks later, and the music was only used for the post-test. So here's our descriptive statistics, and it looks like we lost, or we had a slightly different number of participants in each group, but that's okay. So for the pre-test, the control group, the mean time of the 47 people in that group was just over 8 minutes. The rock group was very, very similar, just a second or 2 less, and the classic group was also pretty similar too. So the pre-test shows us that there's not too many things going on here in the pre-test. So we're pretty confident here that our groups are pretty equal at the pre-test. And then 4 or 5 weeks later, whatever I said it was, we do the post-test. Now the control group is about 752, I would say, 750. The rock group, the average time for the 44 people is 7.5 minutes, and similar for the classical group. Okay, so we got these descriptive statistics that are telling us that the control group that didn't have any music went from this to this, that the group that listened to rock music went from this to this, and the group that listened to classical music, interestingly, went from this to this. So that's descriptive stats, but what we really want to know is, are there any significant differences going on here? So when we plug that into our SPSS, we get this graph, and we can see that across time, pre to post, that all of the groups improved over 4 weeks, and that there seemed to be a similar pattern between the rock group and the classical group. However, the control group that didn't have any music seemed to follow a slightly different pattern. Yes, they improved, but it appears not at the same rate as the other 2 groups. So there's a significant interaction going on here. The 2 music groups decreased their time more from pre to post compared to the control group. So to summarize, in two-way ANOVA and in two-way ANOVA with repeated measures, there's 3 null hypotheses. The interaction is the first one you look at. If there's an interaction, you need to explain it. If there's no interaction, we look at the main effects, which are those 2 independent variables. So when we're looking at ANOVA, if there is a pattern, which you see on the left-hand side here, these 2 groups, there's no interaction. If there's no pattern, then there is an interaction. You see that over here with this green line going in a different direction than the blue line.